Hello everybody. So this is a video giving the solutions for Superquiz 1, problem 1. So here we have a question asking us without using substitution. Okay, that's key. So we shouldn't use a U substitution anywhere. We want to find an antiderivative for the following function, which you'll notice has 1, 2, 3, 4, 5, 6 component pieces, but they're all added or subtracted together, and so we can handle the antiderivatives one piece at a time. All right, so if we wanted to be good with notation, right, we might give a name to this and say, well, either we could say f of x equals this and then write the antiderivative symbol, or we might have called this f prime and then down below just written f of x. Either way is fine. But we just want to make it clear what it is we're computing. So for this first piece, this is just a power function. So we have to add 1 to the exponent. And when we add 1 to the exponent, now this is where some people get mixed up. They add 1 and they get 72. But of course it's negative 71. So we get negative 70. All right, we have a 35 out front. That can just stay there. And then we have to divide by the new exponent, right? Not the old exponent, but the new exponent. So we divide by negative 70. Of course, we could simplify this a little bit, make it negative 1/2 x to the negative 70, but I leave that to you. All right, what about this next piece? Well, this almost looks like x to the negative 1, which would have an antiderivative ln absolute value of x, but it's been shifted a little bit. So we're going to, let's see, first we'll copy the -5. We're just going to guess that it's ln absolute value of x plus 2. And if we, well, I mean, we could be checking these all along, right? So we didn't check the first one, but if I took the derivative, the negative 70 would come down and cancel the negative 70 on the bottom. Then I'd be left with 35x. Now I have to subtract 1 from negative 70, which would be negative 71. All right, so let's see about this one we were interested in. So the -5 can stay. The derivative of ln absolute value of x plus 2 will be 1 over x plus 2. And then you have to multiply by the derivative of x plus 2, but that's just 1, right? So that doesn't hurt anything. So we really do get -5 over x plus 2, right? Or if you like, -5x plus 2 to the negative 1. All right, how about this next one? Ooh, this looks complicated. It's got a secant squared, all right? Not to mention a 4x. Well, here the key is, right, you have to know your differentiation rules. So we need to know, right, that the derivative of the tangent function is secant squared. And once you know that, then this is very easy because you can just say, okay, well, let me just guess here that this was tangent not of x but of 4x. Okay, so then I could check it, and when I check it, say, okay, take the derivative, and I get secant squared of 4x times the derivative of 4x, which is 4. Oops, I have an extra 4, so I better divide by 4. Okay, next one, I have an exponential. Now, exponentials are great because we know antiderivatives are, if you have an exponential to a linear function, it's just good, put the linear function down. All right, so we're going to guess here 3e to the 7x minus 5. We just copy it. And if we check it, we take a derivative, we'll get 3e to the 7x minus 5, but times the derivative of 7x minus 5. Okay, so we're going to have to divide this by 7. All right, next one. Well, again, a lot of you haven't seen the hyperbolics before, but you know, as I told you in the homework, you need to look these up. And actually, their derivative rules are really easy. Derivative of hyperbolic sine, or sometimes called sinh, is cosh, hyperbolic cosine, and vice versa. The derivative of hyperbolic cosine is hyperbolic sine. So if we want to have a minus, we can keep it, and an antiderivative for cosh then would be sinh. All right, and I can guess 3x plus 1. Okay, so but when I check that, I'll get cosh 3x plus 1, and I was like, oh, I'm going to get an extra 3 because of the chain rule, so I better divide this by 3. Right? Well, I guess down here, right, we had to divide all these by, at the end, by what we added. So, okay, fine. Last one. Okay, again, this is complicated looking. All right, we saw this on the first quiz. So we, again, recognize if we take the derivative of the arctan function, we get 1 over 1 plus x squared. So in this case, I've replaced my x by a linear function. So I just guess that this is going to be arctan of, instead of x, of 3x minus 4. And again, if I take the derivative and check, I'll get 1 over 1 plus 3x minus 4 squared. But then I have to multiply by the derivative of 3x minus 4. Okay, so I better divide by 3 so that I can divide by 3 here. All right, and that's how we find the antiderivative without using any substitution.